In this video, we're going to continue talking about ionic compounds. And in particular, we're going to look at the ions that can have multiple possible charges. These will primarily be the transition metals, but there are a few post-transition metals as well. So if we look at a few examples of this on the periodic table, what we see is, for instance, something like chromium can have either a 2 plus or a 3 plus charge. Whereas what we were looking at in the previous video, where we're looking at the main group elements, so the group 1A, 2A, and 3A, those can only have one possible charge. But a lot of these metals in the transition metals and a couple of the post-transition metals such as tin and lead can have multiple possible charges. This is a table showing just a few of these. A lot of these can actually have more than even these multiple possible charges, but these are the ones we're going to primarily look at. When given the name, we want to come up with the formula for an ionic compound that can have variable charges. To do that, the first step we want to do is identify the cation and the anion in the name. And so the cation, as before, is written first, the anion second. And only the cation will have a variable charge. So as we'll see, there is a Roman numeral in parentheses in the name, and that only applies to the cation. So it comes between the cation and the anion, and it only applies to the cation. Then we want to determine the charge on the anion, and because the anion is only ever going to have a single charge, we can just use the charges that we know from the periodic table. The third is then the charge on the cation is given by the Roman numeral in the parentheses between the cation and the anion. So this way we will know what the charge is on the anion and on the cation. And so then we want to increase the number of the cations and anions as needed until the total charges are equal and opposite. So for instance, if we're looking at something like chromium 3 oxide, then we'll want to add oxygens until we have 3 of them and chromiums until we have 2 of them, such that 3 oxygens will have a total charge of -6, and the 2 chromiums will have a total charge of +6, such that those total charges will cancel out. And then we will write the formula with subscripts indicating the number of each ion needed for the charges to balance. So for instance, with our chromium 3 oxide, since we needed 2 chromium ions and 3 oxygen ions, the formula is Cr2O3. And we will go through a few more examples here of how to do this. What we see is if we have nickel 2 sulfide, where we have this Roman numeral 2 in parentheses, that tells us that the charge on the nickel is 2 plus. So nickel 2 is just going to be nickel with a 2 plus charge. And so then we want to find out how many of the sulfides we need to bond to it. And so we see that sulfide is going to be a -2 charge. So if we have one of these and one of these, so one of the nickels, one of the sulfides, we see that the charges for both of them are going to cancel out. So the +2 and the -2 will cancel out. We get a total charge of 0. But now if we look at nickel 3 sulfide, so the 3 in parentheses there is telling us that this has a +3 charge on the nickel. Now we need to again look at sulfide. So if we start off with just one of each, that means the nickel has a +3 charge, the sulfide a -2 charge. So if we add another sulfide, we get to -4, but now we have more negative than positive. So we have to add another nickel, but now we have more positive than negative. So we have to add another sulfide. And so now we have +6 and -6. And so that means that we have 2 nickels and 3 sulfides. So it's Ni2S3. Another example using manganese 2 bromide. Again, the Roman numeral 2 in parentheses tells us that it is a +2 charge. So we have manganese 2 equals Mn2 plus. And we're looking at bromide, so that's going to be a -1 charge. So if we put just one of each together, we end up with a total charge of +1 overall. So the +2 and the -1. So if we add another bromide, then we get that to -2. So now these both cancel each other out, and that means we have a neutral compound that contains 1 manganese and 2 bromides. But now if we look at manganese 3 bromide, where manganese 3 tells us that we have a 3 plus charge on the manganese, what we want to do, again, we're looking at bromide, so we try just putting one of each together. So we have +3 from the manganese, -1 from the bromide, so we still have +2 left over. So we add one more bromide, and then another bromide, so that we end up with +3 and -3. So that means we have 3 bromides to our manganese. Given the chemical formula of an ionic compound, we want to be able to come up with the name for that compound. So the first step is to identify the cation and the anion, and again, only the cation will have a variable charge. Then we want to determine the charge on the cation by first using the charge and number of anions bound to it. So for instance, if there are 3 sulfides, then you know that the total negative charge is -6, and the total positive charge must therefore be +6. And then you would just take that +6, divide it by the number of the cations that are present. That would be given by the subscript in the chemical formula, and that will give you the charge on each of the cations. Then we want to write the name of the cation first, and then use the Roman numerals in parentheses for the charge on the cation, and you put that between the cation and the anion. Then we write the name of the anion after the Roman numeral and give it the suffix "ide," just as before. And so we'll go through a few examples of how to do that here. Now, if we look at this with chromium and oxygen, we know that oxygen is always a -2 charge, and so we can just assume a -2 on the oxygen. -2 comes from the oxygen because our formula here has only 1 oxygen, so we're only multiplying this by 1, so we have -2 total charge from all of the oxygens because there's only 1 oxygen. That means that the total charge must be +2 on the chromium, and so the charge must be 1 times x equals +2. We solve for x, and we find that it's +2, and so that means it would be chromium 2 oxide. Now if we have Cr2O3, again, oxygen has a -2, and so the total charge from the oxygen is -6 because we have 3 of them, so 3 times -2 is -6. This means that the total charge coming from the chromiums must be +6 in order to cancel that out and get a neutral compound. And so that means that the charge must be 2x equals +6, so we want to solve for x. That gives us +6 over 2, so the charge must be +3 on each of those chromiums. So it must be chromium 3 oxide. We can try this with tin and nitrogen. So nitrogen, the nitride ion is N3-, which means that since there are 4 of them, the total charge must be -12. That means that the total charge from the chromium must be +12, and so the charge must be 3x equals +12. So we again solve for x. That gives us +12 over 3, and so that's +4 on each of the tins. And so that means it must be tin 4 nitride. We can try this again. Now it's SN3N2 rather than SN3N4. So again, a nitrogen is always going to be a -3 charge. That means that we have a total charge from it of 2 times -3, since there are 2 nitrogens, so a total charge of -6. This means that the chromium must have a +6 total charge, and so it must be 3x equals +6. We solve for x, that's +6 divided by 3, so it's +2. So that must mean it's tin 2 nitride. So we want to give the formula now for iron 2 oxide. So again, we know that oxygen is -2, and we know the iron has a +2 charge because it has the Roman numeral 2 in parentheses. And so we know that x times +2 plus y times -2 equals 0, where x is going to be the number of irons and y is going to be the number of oxygens. Here we can just kind of easily see that x and y are both going to be equal to 1, thus giving us FeO. Then if we want to try to find the formula for iron 3 oxide, again, oxygen always -2. The iron has a +3, which we know from the Roman numeral 3 in parentheses, and so we know that x times +3 plus y times -2 is going to be equal to 0, where x is going to be the number of irons, y the number of oxygens. And so if we just subtract y times -2 from both sides, that gives us x times +3 equals y times +2. And so this means that if we then divide both sides by x and then both sides by the +2, we get that y over x, which is just the same as the number of oxygens over the number of irons, is equal to 3 over 2. And so this means that the number of oxygens is 3, the number of irons is 2. And so that means we must have Fe2O3 for the chemical formula for this. So here are a few practice problems that you can try. I encourage you to pause the video and try these on your own before watching the rest of the video where I'll go through the answers. So for the first one, we have Cu2S. And so that must mean that because sulfide is a -2 charge, that each of those coppers must be a +1. So it's copper 1 sulfide. The next one we have Cu and then S. Again, sulfide is always -2, so the copper must be +2, so copper 2 sulfide. The next one we have lead and phosphide. So we see that the phosphide, there's two of them, and there's always -3 charge. So there must be a -6 overall, which means that we have to have a +2 on the lead. So lead 2 phosphide. The next one we have 3 leads and 4 phosphorus. Again, the phosphide is always -3, so we must have a -12 overall, which means that the lead must be +4 in order to have 3 times 4 equal +12. The next one we have gold 2 oxide. Again, we always know that oxygen is -2, and the gold we know is +2 because there's the Roman numeral 2 in parentheses, so that means that it's just AuO because -2 on the oxygen, +2 on the gold, those cancel out, so it's just 1 to 1. The next one, gold 3 oxide. Again, oxide is always -2. The gold we have here is +3, so that must mean that we have 2 golds and 3 oxygens, so it would be Au2O3. But anyway, that was everything I wanted to talk about in this video. I hope you found that helpful, and I will see you in the next one.